Hi everybody, we are here with the video for our project in Texas Instruments Analog Design Contest 2010. This project has been done by two of the undergraduate students of Electronics and Telecommunication Department of Bengal Engineering and Science University, Shibpur. This project deals with the security system for detection of fish plates tampering in railway tracks. Since last few years we were planning to do something which will be beneficial for our country, and Texas Instruments Analog Design Contest has given us the right platform. And we targeted our railway system since it is doing quite well since last couple of years, and especially last year's Ganeshwari Express's unforgettable accident has emphasized our thought. Now let us have a short demonstration of our project. This shows the fish plate which are usually present in railway tracks, and this is our flex sensor placed between the nut and the fish plate. This flex sensor has a typical characteristics. As the pressure applied on the flex sensor is varied, so its resistivity is varied. And this flex sensor is used in a sensor network in series with a potentiometer. And as the resistivity of the sensor network varies, so the voltage output coming from the sensor network also varies. This voltage output is sent via a buffer to a microcontroller. We used Texas Instruments ultra low power microcontroller which can operate at a very low power. This shows our transmitter. This transmitter, depending on the signal coming from the microcontroller, sends two different types of bit patterns. This transmitter is actually interfaced to the Ushat pins of the microcontroller, and this shows our antenna. This antenna helps us to transmit. Now actually in normal condition, when there is everything okay with the fish plate, the output voltage coming from the sensor network is high, and the microcontroller compares with the reference voltage and the transmitter sends patterns of ones to the receiver present at the nearest cabin. And the person sitting at the cabin finds that everything is okay at the side. But as soon as the person tries to loosen this bolt, the voltage output coming from the sensor network goes below the reference voltage, and the transmitter then sends a pattern of zeros to the receiver, and the person sitting at the cabin then gets an indication that something is wrong with the fish plate. Now let us see how it works. Now at the present situation, the fish plate is in its normal position, and we can see at the transmitter side the LED is continuously blinking, indicating that the transmitter sends a pattern of ones to the nearest cabin. Now a person tries to loose the bolt and see what happens in the transmitter side. See, you can see the LED blink that was blinking at the transmitter side has now stopped blinking, and indicating that now the antenna is sending a pattern of zeros. So the person sitting at the cabin immediately gets an indication that something is wrong with in the side, and so this way we can prevent the accidents. Now let us have a overlook with our printed circuit board. At the first stage of our printed circuit board, we use this switch. This switch helps us to create pulse signals. Instead of using continuous DC signal, we use this pulse signal to reduce our power consumption. And we saw that this helps us to reduce our power consumption up to 90%. And this switch also inhibits the backward flow of current, which protects the PCB and the entire system. The output of the switch goes to the power management chip, which actually which itself acts in its low power mode, in its power saving mode, and it sends the biasing voltage to all other devices. This output of the power management chip directly goes to the biasing voltage of the sensor network, and the output of the sensor network goes to the buffer. And this buffer is used to eliminate if there is any mismatch of impedance between the sensor network and the microcontroller. And the buffer also prevents the microcontroller from sudden high voltage or noise signals. Now let us have a complete overview of a system. The system might look like a bit expensive, but actually it is not so. It has cost approximately about $195 to $200. And now the system, the entire packaging of the system is done it has to be done to make it cost effective. And one more thing, if suppose a person damages the system before tampering the fish plate, then also the person sitting at the cabin will get an indication, because then also the indicating LED will stop blinking and the receiver will start sending patterns of zeros. So we think that we have done our project to a large extent. Now our sincere thanks goes to our mentor Dr. Chirasri Roy Choudhury, and the entire electronics and telecommunication department of our college has helped us a lot, and the members of other teams also helped us. And last year we attended the workshop in IIT Chennai. There Dr. D.V. Gadre's suggestions also helped us a lot to make this project a success. And thanks to everybody. Thanks for watching.